Good day everyone, my name is Nurul Afika binti Sariman from University Technology Malaysia, UTM, and I will be presenting my project titled Site Selection for Solar PV Farm using Electre in Multi-Criteria Decision Making (MCDM). This project was under supervision of Dr. Shahi Saidin. To begin, I would like to introduce multi-criteria decision making or MCDM. MCDM is a part of operational research that used to evaluate, sort and ranking the alternative based on multiple and often conflicting criteria. There are two types of MCDM. First, MODM that used for optimization problem, and second, MADM that used for selecting and ranking the alternative. MCDM has been widely applied in areas such as in renewable energy, particularly in identifying the optimal site for solar PV farm, which is the core of this study. Due to the increasing impact of climate change, greenhouse gas emission, and the depletion of fossil fuels, there is an urgent need to adopt clean energy solutions. Solar energy is one of the most promising sources. Solar PV system convert sunlight into electricity and offer benefits such as low maintenance, high reliability, and scalability. Apart from environmental benefits, solar development also helps stimulate economic growth by creating jobs in manufacturing and installation. Saudi Arabia, which is high solar irradiance and vast land area, is an ideal location for solar PV farms. Therefore, this study aims to identify the most suitable site for a solar PV farm in the country using MCDM method. This project has three objectives. First, to determine objective criteria weights using Shannon entropy, which relies on actual data instead of opinion. Second, to apply Electre method to rank the cities based on multiple site selection criteria. And third, to validate the result by comparing them with Topsys method. The selection of solar PV site is a complex process that involves multiple factors including climate and sustainability, economic and environmental concern. Using only subjective judgment, such as expert opinion, can lead to inconsistencies. Hence, this study applies to apply objective approach using Shannon entropy to reduce bias and Electre to systematically rank the option. This ensures fairer, data-driven and reproducible design. The purpose of this research is to identify the best location for solar PV farm in Saudi Arabia using MCDM techniques. The main methods that apply is Shannon entropy to calculate objective weight and Electre to perform the ranking and static topsys to validate the result and improve the accuracy. This is the framework of decision-making process. This is the methodology of Electre method based on Shannon entropy. First, construct decision matrix. Then, normalize the decision matrix based on the formula. And then, calculate the entropy for each criterion based on the formula. And then, determine the degree of divergence. Step 5. Calculate the weight for each criteria, and then calculate weight normalized matrix, and then specify the concordance and discordance sets, and calculate the concordance and discordance matrix. Step 9. Determine the concordance and discordance index matrix, and based on the value, determine the ranking for each alternative. Next, this is the methodology of Topsys method that based on static method. First, construct the decision matrix and then normalize the decision matrix. Next, calculate the standard deviation using the formula. Step 4, calculate the correlation coefficient matrix. In step 5, calculate the conflict intensity for each criterion. and then calculate the citric weight for each criteria. Step 7. Calculate the weight normalized decision matrix, and then determine the positive ideal and negative ideal solution. In step 9, calculate the separation measure for positive and negative ideal solution, and then calculate the relative closeness to the ideal solution. And lastly, rank the alternative. The table shows the data that used to evaluate the solar PV site. Next, the table shows the values they obtained after normalized. The table shows the value of local weight and global weight obtained based on the formula. Next, the matrix shows the concordance and discordance matrix obtained by calculation. Based on the score obtained, Riyadh was ranked as the first place, followed by Jeddah, Abaha, Dammam, and Ahsa. The table shows comparison ranking between Electre method and Topsys method. In addition, I'm using SAW ranking to compare the result. To validate the result, I am using Spearman rank correlation. Based on the value obtained, which is 0.9, it is approaching to 1. It shows that it has strong correlation. This study successfully combined Shannon entropy and Electre method to identify the best site for a solar PV farm. Riyadh was ranked highest, supported by strong performance across all key factors. The comparison with Topsys validate the accuracy of the result, showing that combining objective weight with robust ranking methods is effective for decision making in renewable energy planning. For future research, I suggest to use fuzzy logic methods to have better handle uncertainty and imprecise data in decision making. Second, expand the scope by including more cities and additional criteria. And lastly, apply the model in other countries or regions. For future